Hi everyone. My name is Nicola Corti. I'm working for Yelp, and today we're going to talk about the curious case of Android button. So I hope you got like lunch, and we're going to start like smoothly, and then things will go like techie and techie. But if you don't know Yelp, so we are basically a social network. We are based in San Francisco, and we have a couple of offices also in Europe, specifically one in Hamburg that is pretty near, and it's actually an awesome city. So if you're nearby Berlin and you maybe want to stop by in Hamburg, I really recommend it. And our mission is to connect people with great local businesses. So you can basically use Yelp for searching of restaurants, local services, any kind of stuff. And yeah, a couple of things about me. So I'm a core developer, so I'm working for tools for other Android developers. My Twitter handle is Cortinico, and I love to call myself a community lover. So please reach me out. I'm happy to chat about everything. And yeah, those are my hobbies. And this was more than enough for the intro, and let's start. So as you probably noticed from the abstract, today we're going to talk about buttons. Actually, a lot of colleagues of mine and friends of mine ask me, so yeah, sure, but what are you going to talk about? It's like, you just like use buttons, they are there, you drag and drop, and that's it. Sure, that's it, but to make sure that you have those buttons on your screen, a lot of magic is happening under the hood, and if you want to customize your own buttons, specifically also because maybe you want to build your own design system, then you need to know what's happening under the hood. So to give you a little bit of context, at Yelp we have two applications. The consumer app, so it's the one that you can use to search for restaurants, and the business owner app. So the one that we give to our business owner to edit the info. And we try to build them keeping in mind this principle that is consistency first. We want to make sure that the experience that we ship to our customer is consistent. So before delving into the details of what are buttons on Android, I love to start softly with a little bit of buttons history, and I think it makes sense to start from here. This is a Xerox 8010. If you go on Wikipedia and search for GUI, it's the first screenshot that you find there, and it's like the first example of a graphical user interface. And if we zoom here, you will see that there is actually a button. So this concept of button is pretty old and was like still established. It's still just like a rectangle with some text inside. Obviously, we had like some iterations, things evolved a bit, and some years ago we ended up with this skeuomorphic UI. So you might know this tool. This is a calculator, specifically from iOS 6, so till iOS 6, all the design was like following this principle. And the idea behind this skeuomorphic UI is to design something that is similar to the tool that you use every day. So this calculator was similar to the same calculator that you had on your desk till yesterday. So the buttons are the same, you have those shapes and reflections. So the idea was like, I designed something that is next to your reality, so it, for you, is easier to use. And even in this case, this is a slider for iTunes, for changing the volume. The icon in the center is just exactly as the volume controller for your Hi-Fi system. So you're familiar with this concept. If I design something that is familiar to you, it should be easier for you. Sure, but we had some problems. That's why we ended up with, it's called flat UI. And that's just the same calculator with a little bit of different UI. So this principle was like kicked off by Microsoft with Windows Phone 7 in 2010. And yeah, obviously also with iOS 7 2013. So what's the idea? The idea is to streamline the UI, make everything more lighter. So we just like define flat colors, and we don't have like static PNGs that we need to like transfer over the network. Everything will be like easier for developer to create and easier for the consumer to use. And at the same time, the idea was to have like this responsive UI. So if you have something like that, and you need your screen to like change because maybe you want to ship your application for iPhone, iPad, or Android tablets, Android phones, you need to build something that is responsive. Sure. Then we did another iteration. The current status of this kind of design is called almost flat, or also flat 2.0. And this was introduced by Google with a material design in 2014. So what's the idea here? The idea is still to use a flat UI, but add some components that are non-flat. For example, shadows and subtle gradients. With a shadow, I can inform the user which are the area of the screen that I want them to interact with. So all of these principles will end up in the way how you craft your buttons. So we will see during this talk how we will think about all of these principles. So to start crafting your buttons, you basically need to go through 4 main steps. The first one is thinking about the shape. So how you want your button to look like. Then we have the typography. So what about the text that we put inside? Then we have the hierarchy. So what's the role of your button within your screen? And then we have the feedback. So how the button should react whenever the user interacts with that. So let's start with the first one, the shape. So when talking about the shape of your buttons, you usually want to refer to what are the current market standards. So maybe you want to do it rectangular. I mean, you can still do them like as a triangle or as a star, but please make sure that you user test that, because if your users are not aware that that is something clickable, you might have a problem. And also corners, like you want to have rounded corners, maybe yet. There are a lot of researches around rounded corners, like all the devices that you use every day have rounded corners. Those chairs here, they have rounded corners. Why they don't have sharp corners? So it looks like that sharp corners are something that the human perceives as harder and dangerous, so go for rounded corners. And also shadows, as I mentioned before, like flat 2.0, give importance to your widgets. Specifically, when you're starting to take this kind of decision, you might end up between 2 major topic that you have to discuss. First, if you want to base your design more on your platform or more on your brand. So if you're just establishing now your brand, and you're maybe a small startup, go for the platform. There are a lot of guidelines that explains how buttons on Android should look like, so go for that. On the other end, if you're really good, if you really have a strong brand awareness, go for that and make sure your brand is within all of your widgets, and make sure your widgets are consistent across all of your platforms and across all of your product. Talking about this was one of the topics that was discussed at this year's Google I/O. Google recently announced the Material Components Library. If you saw the Google I/O, they basically introduced this concept of shaping, and they want you to use the material design to drive your brand with that. Unfortunately, this material design components library is still in alpha, so today we're going to focus on what's the support library, and maybe in one of the future iterations of this talk I will update everything, but still it makes sense to see what's going to be like in the near future. We should have something like that, so we should be able to set at the theme level how our rounded corners, how our widget should look like across all of our app, and we will hopefully drive brand with these attributes. But let's step back to the material design. So I talked a little bit about shape, I talked a little bit about rounded corners, and now it's time to talk also about shadows. In the material design environment, everything is defined as a material sheet and as an elevation. So the more important the component is, the more elevated it is. So for example, at the top, we have the dialog or the picker. There is something that we want the user to interact with, and they will have a higher elevation. The higher the elevation, the darker, let's say, the shadow will be. But to really understand how the shadow is computed on Android, we need to know what's the light system. And on Android, oh, unfortunately here we don't see so well, but anyway, those shapes over there are lights. So, and the phone should be like vertical over there. So basically we have two main lights. One is the ambient light, is the one coming here from the right, so it's just in front of your device. And the other is the key light, is coming from the top. Those two lights are casting shadows that will end up on all of your widgets once they define an elevation. So let's see how this shadow will look like. The key shadow, given that the key light is from the top, will be all below the widget and on the side. And the ambient shadow will cast a uniform, the ambient light will cast a uniform shadow all around your widget. So the resulting shadow will be something like that. So like a uniform shadow with like deeper shadow on the bottom. So why I'm telling you this, because this is a system that you have to interact with every day. Like if you create a custom view and you set an elevation, you will end up having this kind of light. This is something that you can't actually modify. You can just set the elevation, but it's like how the Android framework works. And specifically, given that we have this key light, if you have a widget, like a button that is on the top of your screen, and then you move it to the bottom, the shadow will change. And here we should have this animation, and yeah. So the shadow on the bottom of this button is way, way darker and different. Why I'm telling you this? Because you might end up discussing with your designer, because maybe they want like, I don't know, a blue shadow, or they want like a custom shadow that is this specific behavior, but you can't change it. This is how Android works. You need to deal with that, or you need to provide a PNG asset for the background. That will be static, but it's up to you. I'm honestly happy with this behavior, but just like that's how it works. So now we talk a lot about design stuff. Now we're gonna deep dive inside the Android framework to see actually what's a button, how those things are implemented, how we can tune them. So let's start actually. What's an Android button? So we start with this class, Android widget button. If you use the support library, you might use also this other class, app-compat button. Since they are like still written in Java, they are obviously Java object, and they're custom views. So there is view in the hierarchy here. But the point is like there is also another class there in the middle, and it's actually a text view. So I think this is one of the most important points. Buttons are text view, nothing more. If you want to implement your custom button and you subclass from view, you're probably doing a big mistake. So subclass from app-compat button or from button and start from that. To convince you about this, those are the number of lines of code. So button and app-compat button are doing nothing. It's full of comments there. Like all the logic, specifically a lot of logic for the accessibility is inside the text view. You don't want to lose that, that code. So pay attention where you subclass. And specifically in this new material components library, they introduced this new component called material button. And this is a subclass of app-compat button. And it's still 800 lines of code, nothing really magic. So I said that there is button and app-compat button. Actually, you can consider them as the same thing, because when you start your layout, you just like drop in a button, you set the width and the height, and writing this is equivalent to writing this specifically if you're using the support library. So if your activities are app-compat activities, you will see that they will be basically injected. So if you open the app-compat button source code, yeah, it extends a button, and in the comment they say like, this will automatically be used when you use button in your layouts. If you use the support library, blah, 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 blah. So we're gonna focus on button and consider them the same kind of family of widgets. So the support library is giving us 4 default styles for buttons. Those. compat.button.colored, .borderless.colored. Again, in the new material components library, they're adding new kind of styles, but are still in alpha 3, so I'm not gonna talk about that because they might change. And those are like how those styles looks like. If you want to customize your buttons, you might want to have a look to see what's inside there to like extend those styles and understand how things are set up inside and create your own. So since we want to work on the shape level, let's focus on the first one. So for sake of simplicity, I'm gonna focus my attention on API 21+. I hope you're fine with that, also because this Twitter account tweeted 21, like in April. So unfortunately, there is no efficient way to render shadows and ripples effect on APIs below 21. So do not like things so much complicated, only API 21+. So if you open this style, you will end up in the base style of the separate library. And if you open the base style, you will end up inside this other style, Android widget material button. If you CMD B there, you will end up inside the framework. So that's the Android source code, and it's there in a folder of your machine. So you can just like see what's inside. We will end up in this file called stylesmaterial.xml, and that's the style. So this is the style that will be applied to all the buttons by default whenever you use them in your layout. And let's see what's inside. Just 8 attributes, not so much. Other things are inherited from widget.material and widget, but some of them are pretty important. The min height and min width, particularly the min height is making sure that the button is big enough to be making sure that it's touchable. Then we have the gravity to make sure that the text is in the center. And the most important thing that is where like all the magic of buttons happen is the background. As I said before, buttons are just text view with a background. Let's open this file. So button default material, it's a resource file. We open that, and it's just a ripple that is applied on top of an item. So this ripple requires a color, and so this will be this color here is a theme attribute, color control light, and this is a color that is used for all of your widgets whenever they are alighted, okay? So in this case, this will be responsible of having this ripple effect that is tend to be gray. This color can change based on if you're using the light or the dark theme, but just like you can ignore that, but know that there is a ripple applied on something. So this ripple is applied on this item. This is a button default material shape. And actually now I'm gonna explode this file and copy it inside there. So what we have? The first thing that we have is an inset. So the inset is responsible of this. When you drag and drop your widget from the Android Studio Designer inside your layout, you will have something like that. So you will have the button is inside this blue box, but there is some area on the on left and right and top and left, and it's actually 6dp bottom and top and 4dp left and right. So those insets are there to make sure that there is enough space to render the shadows. Okay, you might end up with some headache with your designers because things are not properly aligned. So you might know that those inset is there. Actually, in the new library, they also exposed this measure as an attribute so you can control them. But at the same time, once you control them, pay attention that you have enough space for drawing shadows, because otherwise your shadows will be cropped, and it's not really cool. So inside we have a shape. We decided that we want rectangular button. So here we define that the shape is a rectangle. And we tint it with color button normal. This is another color attribute, and this is responsible of the default color of your button being gray. In this case, this is rectangular here. Then we set the corners. The material design system by default set corner radius to 2dp. Then we have a solid background to white, and we have some padding to make sure your text doesn't bleed on the border. That wouldn't be so cool. And actually, like, yeah, I showed you like 4DP, 2DP. Obviously, they're not coded there. We have dimensions, but this is how the file of the background of a button looks like. It's not so complicated, but it's like you can go through step by step and see what's inside. So next step, typography. So yeah, this might be worth to do like a talk only on this, but we don't have time. So for buttons, usually on Android, use a verb. Avoid having weird buttons like awesome. Sure, what it means, like this is doing what? So try to use a verb and action. Also, on Android, buttons are usually all caps. Now they're changing a bit, but they tend to be all caps. So go for that. And again, like principle of least astonishment, like the user should like guess what's going on if they click on a button. They should not like try to understand, like if it's login, you press there, you should perform a login. That sounds obvious, but might not be. So in the code, that's pretty trivial. You just like set the text with the text attribute. As I mentioned before, this style is the default style applied to your button. So even if you don't put it there, that will be applied. And let's have a look again at that style. One of the attributes that we skipped before is the text appearance. Actually, text appearance is another theme attribute that resolves to this. Text appearance material button, and inside here we have the spec. They are making sure that the button looks like this one. For example, text all caps set to true. So if you want to change text appearance of your button, you just like override the text appearance attribute and provide your own. Okay, so till now we are able to do like gray buttons with black text. Might be cool, maybe not. Let's go ahead. Hierarchy. So you want to give importance to your button. And you want to make sure that the user presses the right button inside your screen. So the first thing that you need to do to define hierarchy is define your color palette. So make sure that your color palette is well defined. You have a color background, a primary color, a secondary color, and like fix that. Once you fix that, then you can use contrast to define hierarchy. So usually your primary button will be in high contrast with your background. So for example, will be your accent color. Then you will have like a negative button that it tends to be on a medium contrast with your background. And then you will have a secondary button that is usually in low contrast with the background. The idea is like, I want the user to press that buy button because it's doing, I don't know, maybe a purchase process, so it makes sense that it continues. So that button will be primary and will be in high contrast, so the user will immediately see the button. In the material design environment, hierarchy is defined with these three types of buttons. The first one is the fab, that we're not going to talk about. Again, I'll talk on that, might be worth. And then we have these other two. The one in the center is the raised button, so that has like a 2DP elevation. So a little bit of shadow, and the other is a borderless button. So this one has no shadow because it is directly printed on the lower material sheet. In our case, like we started from these and we said, okay, those are good, but we want to have our own buttons and we want to like define which buttons we need. So we ended up defining this group of 5 buttons that solves more or less all of our use cases. And that's like how we build those kind of buttons. So again, we start from this style. In this case, we want to add colors. So we start from the colored one. Again, I'm going to restrict on API 23+, because color state list was, not exactly added there, but the support that I need to show you this case is in API 23+, but everything have been backported, so is everything available in the support library. So if you open this style, again, we end up in the base style, and then we end up in one of the Android framework style, widget material button colored. We open again this file, styles material. This is the style that we saw before, so the one for the gray buttons. And then we have this other. So the thing that we put this dot colored, if you're not familiar with that, is like styles hierarchy. So everything that is inside this dot colored is everything that was in the previous style plus what we define here. In this case, just 2 attributes. That's pretty easy because we want just to change 2 things, right? The background and the text. And in this case, we are changing the text appearance to be white, in this case, and the background. If we open this button colored material, let's see what we have inside. Again, is a drawable file. And yeah, okay, wall of code. Sorry guys, but this is like similar to the structure we saw before, like ripple, item, insert, shape, corner, solid, and padding. So it's really, really similar to what we saw before. Just one thing that is worth noting that changed is this one. Button color background material. So this is the tint for the shape, and previously was button color default, like the gray color, and in this case, if we CMD here, we will not end up in a color, so this will not be a static color, but it will be a file, button color background material.xml. And inside this file, we have this. This is a color state list. So it's something that the Android framework is providing to pick the color based on the state of our widget. In this case, we have 2 items. The first one is the one that will be picked when the state enabled is set to false, and the other one is the general. In the first one, we have In the first one, we have the color set to color button normal, and we have an alpha. So we are watching the one that is state enabled false, so when the button is disabled, and we want to achieve something like that, so gray with gray text, and we are applying this alpha on top. This is also what is causing this gray effect to the text. In the general one, so the color that will be picked for every state that is not picked by the first one, we set the color to color accent. In this case, blue. But, I mean, your color accent. Sure. Okay, so far so good. You already have styles from the support library that are allowing you to have a gray one and the color accent one. Sure. So let's say now you want your secondary color. So you want a red button, like the one. How do you do? So there are actually 2 ways. And this is like where things are, I don't want to say getting complicated, but like I would love there to be more simple, honestly. You can use a theme overlay, but the theme overlay is something that you can provide only with XML, or you can use the background tint attribute. Let's see how they behave. So in this case, we need 2 buttons. We set the style to this compact button colored, and again, we want to achieve this red one. In the first one, we use the theme overlay. So we set the theme there. Setting the theme on a widget allows us to override the theme only for that part of the XML tree. So in this case, only for that button, the theme will be different, will be my red button. In the other case, we set the background tint to color red. Sure, okay. This theme I haven't showed you actually how it looks like, so let's define it. So we have this theme called My Red Button. The support library is providing us those theme overlays. So those theme overlays styles are styles exactly to do this kind of stuff, like to override specific attributes. They don't define everything there. So if you want to like color a specific button, you can use them. And in this case, we set the color accent, we override the color accent there. So in that context, the color accent will not be our blue, but will be red. Sure. Or works fine, but I mean, you have them. Sure. But if you try to disable them, like if you call like dot is enabled equal false, you will end up with something like that. That it's wrong, actually. So the wrong one is the second one. Previously, for 2 reasons. First, because if you mix theme overlay and background tint in your app, you will end up having inconsistent disabled state. That is not so cool. And also because you want your colored button and not colored button to be disabled and look like the same. So why this is happening? So this is happening because in the background tint, you can't just pass a color, a static color like a red. You need to provide there a color state list, as we saw before. So this is the color state list that we saw before to doing the blue color, and you need to like change those color accent and provide there the proper color. So this like, sure, but I just want a red button. I mean, do I really need to do all this crazy stuff? Unfortunately, yes. So that's how things are. So the solution that we ended up taking is if you want to have something that is flexible enough, especially if you want to do A/B testing on your styles, what you need to do is have a util class where you create basically all the drawables, all the color state lists, everything that is like in the XML, you create it at runtime and you provide it. And basically the approach that we ended up taking is I exposed to my developers a color attribute, like Android color, that is missing now on button. There is no Android color on button. And from that attribute, I create all the states and all the colors from that one. This is up to you if you want to have such a flexibility, because maybe you need to iterate on your buttons or not. I don't know, it's up to you. But it's like, unfortunately, it's painful here. So next step, last one, feedback. So for the feedback, we always need to remember that we want to like provide a feedback whenever the user is clicking on them. First, because like, yeah, buttons are alive. We want to make sure that whenever the user clicks there, it thinks that something happened. Because if you do no animations, if you don't animate the shadow, then the user may think like, I've actually clicked, or was the app blocked? What happened? Also, buttons have states. Like, as I mentioned before, you maybe want to disable them. Please stop doing things like to disable the button, change the background to be gray. That's not disabling them. Like, you have all the accessibility that are completely screwed up because your button is still enabled, it's just gray. So like letting the user think that it's not enabled, but it's actually enabled. So that's really bad. I saw that a lot on GitHub, so pay attention to that. Use repls. Repls are awesome. They already handle a lot of states inside. If you have a look at the REPL drawable code, you will see that they will check if the widgets where they're applied is like focused, disabled, enabled. And also, don't forget to animate the shadows. This is done by default by the Android framework, but if you want to customize that, you need to make sure that you're still animating them. We will see how. So, stress your designers to have like the whole life cycle of your buttons. Buttons are not just color rectangles. They have like a life. They can be disabled, they can be pressed, they can be focused. You want ideally to end up with something like that, so the collections of all of your buttons, more or less, and then iterate on that with your designers eventually, and like once you have them, start coding them. On Android, you have like, I think 17, 18 states. And also you can like define your own custom states. So you can't handle all of them. Some of them are like useless, but like, I mean, useless for most of use cases. But like, yeah, you definitely need to handle at least enable, disable, focus, pressed, and hover if you also have like mouse support or things like that. So don't forget about states. Shadows. So shadows on Android, as I mentioned before, are computed with the elevation attribute, and you can animate them providing this other attribute that is called translation Z, and that's like the dynamic part of your elevation. So basically you define like the static elevation and then you animate the translation Z to change the shadow of your button when, for example, the user clicks there. So how you can customize this. So on Android, you just like set the elevation like this, like 2dp directly on the widget. Sure, maybe the designers come to you and say like, nah, 2dp is not enough for our button. We want them to be 8dp. Sure, you change them, and nothing happens. Like you put it to 8, you put it to 10, you put it to how much you want, will always be 2dp. Why? If you go on Stack Overflow and search like why elevations of my button are not changing, the thing that they suggest you to do is this: set state list animator to null. Sure, just like copy and pasting for Stack Overflow works, okay, but why? Why you need this? Because again, if you go inside the styles of the Android framework, open this, you see that there is like a state list animator that is set to a value, and if you open it, that file, so button state list anim material.xml, we will end up with this. So this is a state list animator. It's another tool provided by the Android framework that allows us to animate attributes when the state of our widget is changing, and explain how those attributes should change. In this case, we have 3 items. The first one is when the button is pressed and enabled. The second one is when the button is enabled. And the last one is all the other cases. So, for example, when the button is disabled. So what we want to achieve? We want to achieve 8dp. So this is like the default Android. Let's say that we want to achieve 8dp elevation when the button is pressed, 2dp when the button is not pressed, and 0 when the button is disabled. So in the first case, we have 2 object animator. The first one is animating translation Z to reach 6dp. So this will move this, animate the value of this attribute translation Z to 6dp, and this other animator will set the elevation to 2dp, like the default one. For the rest state, so when the button is not pressed, what we want to do is animate a translation Z back to 0 to have this like shadow effect that goes back to 2dp. So we will animate this translation Z back to 0 and the elevation to 2dp. And now you may also ask, yeah, okay, but why don't you animate just translation Z? Like, why do you reset elevation always to 2dp? You need to do that because you also have this disabled state, and in the disabled state, you are setting both translation Z and elevation to 0. So in this case, specifically these, if you disable your button and then you re-enable them again, elevation will be blocked to 0 and will not be back to 2dp. So that's why those 2 attributes need to be animated all the time. This is how you do a state list animator to change the shadows of your buttons. So, and with this, like that was mostly everything from me. Like a couple of takeaways. First, again, consistency first. So we did all this work to make sure that our apps are mostly consistent. So that's what we try to achieve every day when we are developing them. It's hard, obviously, because apps are pretty big. But like we try to create the framework that fits our needs. Don't be afraid to deep dive. A lot of like friends of mine, they just say, oh no, this is in the Android framework. I don't know if I want to see that. Sure, it's like how things are done. So don't be afraid. And buttons are alive. Like they have their own life cycle, like enable, disable. Don't forget about that. And also they are alive from another point of view. This is a work that you will not do just once. You might want to iterate on like how you are setting your buttons. So try to create something that is as flexible enough to solve your problems. And that's all for me today. We are hiring. Oh, I skipped that. Yeah, sure. So you can reach me out if you're interested. Those are like our links, and now I'm happy to answer your questions.
Thank you so much. Questions? I was actually working...
There is one there.
Hi. First of all, great talk. Is it possible to have the color of the button come from the backend as a hex code, and also apply the ripple effect?
Yeah. So you can have them. So usually we tend we do that for some widgets, not specifically for buttons, because we are a lot of teams. I think 80 engineering teams at Yelp. So, and making sure that teams are doing things that comply to our style guide, it's not always easy. So we're trying to if you're running an experiment, a specific feature that you want to have colors coming from the backend, you might do that, but we prefer to have them static and fixed to try to achieve this consistency first stuff. You can do that anyway. You can still have an endpoint that you call at the beginning of your lifecycle application, then get the colors, the RGB or whatever you need, and then creating everything at runtime, having the background and the text that is colored given those attributes. You can do that. It's a bit tricky, but yeah, you can do that.
Thanks.
And slides are online, I guess, on my Twitter account if you want them. Yeah.
Hi. We say that the UX elements, the UI elements are associated with the real-life objects, like the buttons.
Yeah.
Why do we elevate a button to up when you press that and not to down?
That's I know. It's actually
this is probably not a question to you, but to the material design team.
I know. That's how they decided to do it. Actually, if you use Polymer and they have this sort of material paper stuff, the buttons are behaving in the opposite way. So they have shadow, and when you click them, you're squashing them against the floor. Okay. It's your system. I gotta say that it's you can user test them if you want. At the end of the story, what it makes sense is just that you're consistent with your UI, and once you decide, okay, so for every widget that I interacts with, I want to add +6 elevation, 6 dp elevation, and then define that globally and make sure that it is consistent. That's the best suggestion that I can give.
Your question.
Yeah, hi. I have a question that's more related to text view and not so much, but the button, as you said, is a subclass of text view, and it's related to typefaces, specifically the font files, I'm not saying. So one issue that, at least at my company, what we often have with to match up with the design mockups is that the designers often measure distances to the text when it comes to text views, and there's this sort of inherent padding in all this. I don't know if it's part of the font file or something like that, but so for example, say okay, this has to be I don't know 5 dps from the top until the top of the letter C or whatever. So, and how do you deal with that?
Yeah, to overcome this, basically we defined as I showed before, that the min height and the min width of a button is I think 48 and 88 dp. Now they changed a bit with the latest library, but they used to be fixed. Again, we define our own size for buttons and what's the minimum. And once you define the minimum, you already solved some sort of problems, because we always ended up and oh, okay, so this button is 70% of the screen, and then we have too much spaces on the side, while we always basically have two kind of buttons, either the full width that occupies the whole screen, or the let's call it wrap content button, where the button is measuring itself and is done. Even sometimes we go back to designers and says this is our style guide library, was designed by other designers and implemented by those developers. Those are the rules that we follow in all of our application. And I'm sorry for your extra 8 dp, but they will go away, because that's how our buttons are. Unless they really have strong concerns, and those maybe 8 dps will make the difference. But it's we tend to try to be more consistent as possible.